you think of?
Like football.
Football. Okay. Elaborate. When is there an intercept in football?
One team goes this way, and then that team gets it and it goes back this way.
Yeah. Alex? Yeah, two lines intersect, right? They would intersect there. But the interception in football, right, is when another...
Defense picks off the offense.
Yeah, defense picks off the offenses, and they catch it, right?
Yeah.
Is it called an interception if they block, if they just knock it down? That's just incomplete pass, right? Yeah. So, in algebra, we have intercepts. We get two of them, usually. And we get an x and a y intercept. So I want you to write down these definitions, please, in your notes. The first intercept we're going to be looking at is what's called the x-intercept. And we call it the x-intercept because it's the x-coordinate of the point where the graph intersects, that should be it, intersects with an S at the end, the x-axis. Yeah, fix that right now. It's bothering me. Okay, and then the y is just the same. So your y-intercept is the y-coordinate of the point where the graph intersects the y-axis. Okay. So we got an x-intercept and a y-intercept. Why are these important? Well, they're important because if I were to graph a line, you need a minimum of how many points for a line? Two, right? Everybody right now take your pencil if you're done writing. Try to balance your pencil with just one finger. Can you make a line balanced? Use the tip of your finger.
Oh,
Can you tip the top of it? That'll be a little bit easier. It's a little bit harder to balance with just one finger, right? With one point. You got it? Now use two fingertips. Does it make it a little bit easier to balance? It does. It should, right? Two. There, you got it. Some of you guys are pretty good at balancing.
You mean that way? Oh.
No, like this. This is kind of
How is
hard.
that possible if there's only one end?
Like two, I can balance it a little bit better than one, right? My fingernails get in the way. I can balance it with one. Not really.
So I meant like this.
Okay? So, we need a minimum of 2 points to make a line. Okay? We use usually 3 or 4 or 5 just to really make sure that my line is correct. Okay? So when you are graphing lines, you should have at least 3 or 4 points on your line when you plot it. But you need a minimum of 2 to get the line to be created. Well, these are 2 special points on the graph that would be used to create a line, the x-intercept and the y-intercept. Okay, so the first thing we need to do is, can I identify what an x and y-intercept looks like? So if I gave you this graph, and I gave you a linear line, okay, your x-intercept is the x-coordinate of the point where the line crosses the x-axis. Well, my x-axis is the horizontal axis. Where is the line intersecting with the x-axis? Right, let's do this in, oh, we have blue. We'll use green. Hopefully we don't have too many color-blind people in the room. That would be my x-intercept, the point where it intersects the x-axis. What are the coordinates of that point? It's -2, 0, right? So your x-intercept is the x-coordinate. So it's not going to be that point. It's only going to be the x-coordinate of that point. So when I go to write my answer and I say that my x-intercept, and I'm just going to put a little colon here, is going to be -2.
Enter pets.
Interpets. Oh gosh, I'm losing it. My x-intercept. Got better? There we go. Intercept, thanks for noticing, Colin, is -2. Do not write x equals -2. That is not the same thing. That is wrong. Don't put that as an answer. And some of you will. Don't do that. That's an equation. Your x-intercept is a coordinate. So it is -2. Your answer is not an equation of x equals -2. It's two different things. All right, so now let's pick the y-intercept. So if we look at the point where it crosses the y-axis, let's do this in purple. It's right here. What are the coordinates of that point? 0, 1. My y-intercept is the y-coordinate of the point, so it's just going to be 1. Do not write your answer y equals 1. I will not count that. It's not the equation y equals 1. It's a coordinate, 1. Got the difference? Don't do that. Don't do that. All right. So we should be able to get x and y intercepts from a graph. That's pretty easy, right? So now can we get x and y intercepts from an equation? How do we do that? So I would put this stuff in your notes because this is a little bit more work. So if I gave you the equation 3x minus 2y equals 12, is that a linear equation? Yes or no? Yes. The exponent on the x is 1. The x is not in the denominator. X and y are not being multiplied. It's in standard form, so it is a linear equation. Now let's think back. I'm going to flash back to this screen right here. My x coordinate had a 0 in the ordered pair. Where was that 0 located?
Right in the middle.
In the x or the y? The y had a coordinate of 0, right? Would that be true for any graph? So if I come up with a different graph. So let me erase this. Oops, erase all. So if I make a quick graph here, and I made this as my, oh, that's the same thing. Let's go this way. Let's pretend that's at 3. What would be the coordinates of that x-intercept? 3, 0. Let's just do a different color. What about my red line? What would be the coordinates of that? 10. That'd be 1, 0, right? What about the coordinates of this one?
Is that pink or
Negative.
It's pink. 1, 2, 3, 4, 5. Negative 5, 0. So what's the pattern between all of these x-intercepts? The 0 is always going to be in the y, right? Doesn't matter where I put my line. So I can put my line all the way out here. I'm still going to have a 0 for my y, right? I can put my line all the way out here. Ooh, we're going to go brown. Blah. Okay, I'm still going to have a 0 as my y. So when we go to do this problem to find the x-intercept, we already know what the y needs to be. What does the y need to be? The y needs to be 0, right? Hello? Yes. Sure. Right. So we are going to input 0 in place of y. So what I want you to do right now is substitute in 0 for y. Hayden, you're being dismissed. Here's the homework. Emma? Yep. So instead of a y, we're going to input a 0. Bring down your 3x, bring down your minus, bring down your equals 12. Can you solve that equation for x?
Yeah.
Yes. Well, negative 2 times 0 is 0. So now I'm left with 3x is equal to 12. So x is equal to 4. Now this is where you guys are going to lose points because you're going to stop and you're going to say, circle x equals 4. But what did I say before? X equals 4 is not your final answer. Okay? Your final answer is going to just be 4. So however you want to write that, you need to think about it. Yes?
Would it be x intercept and then the...
Yep, so then you would just write x-intercept is 4. Or, if you want to, well, I would accept ordered pairs, but your x-intercept is 4. So let's just leave it like that. Let's not even do an or. All right, so let's find the y-intercept. Now, what was true about all of the y-intercepts?
X is 0.
Yeah, so no matter where my line crosses, let's say this is at 0, 2, or let's say this is at 0, negative 2, or this is at 0, negative 4, or this is at 0, 5, your y-intercept, the x is always going to be 0. So to find the y-intercept, we're going to do the opposite. I'm going to turn my x into the 0 and solve for y. So minus 2y equals 12. 3 times 0 is 0. Negative 2y is equal to 12. Y is equal to negative 6. So my y-intercept is negative 6.
Yeah.
Sometimes you'll hear people talk about, this is how I personally do it, they call it the cover-up method. To solve for your y-intercept, you literally cover up your x. So sometimes you'll see me just put my hand over it. I know you can see it with the projector shining in my hands, but y would then be what? Negative 2. If I covered up my y part, x would be 3x equals 12, so x would equal 4. Right? So sometimes you'll see students just put their pencil physically over top of the x term or put it over top of the y term and then solve for it. All right, so let's see if you can do this one on your own. Find the x and y intercepts of 2x minus 4y equals 8. So just find them right now, and then we'll graph it using our x-intercepts. If you just use the cover-up method, that is fine. But you should at least show the negative 4y equals 8. If you want to abbreviate intercept to just int, I'll let you do that. Your answer is not x equals 4, at least write x int is 4. So now, can I use those to make the graph?
Yeah.
Yeah, so make a quick lazy XY axis. Doesn't have to be fancy. Yeah, sure.
So I see like X or Y is like Z, like 3D.
Yes.
Like,
Yep.
Okay.
Yeah. Z is the three-dimensional. All right, so and be careful, if you're doing the cover-up method, make sure you don't cover up the negative with the y term. Like that y term would be negative 4y. Don't cover up the negative with it. So make sure you carry that over with it. Okay, so my y-intercept is negative 2, so that means on my y-axis, I'm going to put a dot at negative 2. and my x-intercept is positive 4. So on my x-axis, I'm going to put a dot at 4. And then I'm going to connect those 2 points with a straight line, putting arrows on the end, because it goes on and on and on and on forever. Okay? All right, let's end with a word problem, our favorite.
No, thank you.
So we have Trish, who can run the 200-meter dash in 25 seconds. The function f of x, I would write this in your notes, equals 200 minus 8x. Gives the distance remaining to be run after x seconds. Graph this function and find the x-intercepts. All right, so let's work on finding the x-intercepts. So in the past, f of x we knew stood for y, right? So whenever I see that f of x, I'm just going to turn that into a y equals 200 minus 8x. Now, we could just do the cover-up method. If I cover up x, what do we get for our y-intercept? 200. That's nice. But if I do the cover-up method this way with the y, well, I can't easily get x because it's on the same side. So before we want to do the cover-up method, let's get it into standard form. How do we put something in standard form? You guys wrote this in your notes. Yeah, so standard form is ax plus by equals c, where you need to get x and y on the same side. So if I wanted to move a negative 8x to the other side, I'm not going to divide, it's going to add. So it's going to change signs. So if you move it to the other side, it's going to change signs. Right now it's a negative, so it would go to a positive 8x plus y equals 200. So we see how that...
Why would you change it to a positive?
Because to get rid of it, you have to add it for it to go to 0 x's, right? So then it would be a plus 8x over here. Now let's do the cover-up method. So my y-intercept is easy. That's 200. What's my x-intercept going to be? So if I do my cover-up method here, I'm left with 8x equals 200. What's 200 divided by 8? 25. Thank you. Okay, so there's my y and my x-intercept. So let's graph it. Am I going to have any negative parts to this problem? Nope, we're talking about running. So just the first quadrant. X represents time in seconds. What does our y represent? Distance. Is it in meters? Yep. Distance in meters. All right. We need to get up to 200. Maybe this would be a good option to do that little zigzag, huh? Or that little zigzag we were talking about. So we can jump up to 200 right away. And then jump by what? Fives? So 205.
I thought you were talking about the X.
Oh.
I did it by 50s.
By 50s? All right. We could do it by 50s. We could do it by, yeah, let's do it by 50s. Well, I would do it by 20s because 2 seconds would change it by 16 each time. So you want to probably do something with a multiple of 8. But anyways, do whatever. So we're starting at 200. Time is, we have to get all the way to 25 because I want my x-intercept. So if I jump by 5, 10, 15, 20, 25, because I know my x-intercept is 25, so that means my graph is going to graph there. So if my y-intercept is 200, and let me do this in a different color, my x-intercept is 25, can I make a line using those 2 points? Sure, just connect them. I don't even need to figure out the stuff in between. That's nice. What does each intercept represent? What does the 200 represent? Be more specific. It's the starting distance right? At time 0, you're at 200. What does the x-intercept represent?
Time.
How long it took to
Get there.
finish, to get to your distance to be 0, right? All right, so relax, we got 3 minutes here.